Hi, everyone. So we actually have just one tiny topic that I somehow bypassed completely, but it was only 2 pages. So I want to just record the lecture right now and share that with you so that you are not like, wait a second, how do we do this part? So this is found on page 14 of your Unit 5 guided notes, solving nonlinear systems by substitution. What I've actually done for problem number 12, part A, is the following. Take a look. So what we have here is x squared is equal to 8y plus 1, and then x minus 4y is equal to -1. So I wanted to solve the nonlinear system by using substitution. So what I ended up doing was I actually focused on getting x by itself here, just because I felt that that would be pretty straightforward in terms of, plugging in and making that substitution. So I solved for x and notice that in my first equation, I have an x that can be replaced with these contents, right? So 4y minus 1 squared is equal to 8y plus 1. So I went ahead and I squared that 4y minus 1. I did the side work here just so that you can understand that I opened up 4y minus 1. So now I'm going to replace it in the equation. So I have 16y squared minus 8y plus 1 is equal to 8y plus 1. What I'm going to do at this point is I'm going to set this equal to 0 by bringing over 8y and by bringing over 1. Notice that I'm left with 16y squared minus 16y. These end up canceling each other out, and that leaves us with equal to 0. At this point, I'm definitely going to use factoring in order to solve because I do have a GCF. My GCF in this case is 16y. When I factor that out, I'm left with y minus 1. So we have 16y times y minus 1 is equal to 0. We are going to set each factor containing a variable equal to 0, and we solve. We are so used to this by now that at this point, hopefully you will find that it's very straightforward to say, okay, well, that means y is 0 and y is also 1. What we end up doing with these two solutions is that we're actually going to plug it back into one of our equations. So typically we'd plug right back into our original equation, but because I'm confident that I had no mathematical errors by bringing that 4y over, I'm actually going to plug in y equals 0 into the equation to find its corresponding x. And then I'm going to plug in y equals 1 into the equation and find its corresponding x. So we literally do this twice, okay? So if it helps, I'm going to write when y equals 0, we plug that in. So 4 times 0 minus 1, and we find that x is equal to -1. So one of my solutions is the ordered pair -1, 0. I then have to say, well, I also know that y is equal to 1. So when y equals 1, we have x is equal to 4 times 1 minus 1. 4 minus 1 is 3. And we find its corresponding x value. So when y was 1, x was 3. So your solutions are -1, 0, and 3, 1. So we end up having to find the 2 points where the two graphs intersect. Here we have a parabola, and here we have a line. Okay, so it's an alternative to graphing and then finding the points of intersection. Let's take a look at part B. Notice here that we have 2x squared plus 3x plus 7 is equal to y minus 1. But then the next equation tells us what y is. Y is x squared minus 2x plus 2. So I'm immediately going to use this and substitute into my first equation for y. So let's figure out what we have here. We have 2x squared plus 3x plus 7 is equal to x squared minus 2x plus 2 minus 1. Let's clean up and set this equal to 0. So I'm going to subtract x squared. I'm going to add 2x. And then 2 minus 1 is 1, so I'm going to subtract 1. I essentially combine those, and I'm just bringing that over. So all of these terms are essentially combined. So this whole thing goes away, okay? So we have 2x squared minus x squared is x squared. 3x and 2x, that's 5x. 7 take away 1, that's 6. And that's equal to 0. I'm going to attempt to factor this again. We want factors of 6 that add to 5. Unfortunately, that's not going to work. So factoring is not an option for us. I would complete the square, except if I bring the 6 over and then I cut the 5 in half, I'm dealing with fractions. So my preferred method in this case is to use the quadratic formula. So we have x is equal to negative b, here's b, plus or minus the square root of b squared minus 4 times a is 1, times c, which is 6, all over 2a. So let's do this math. We have x is equal to negative 5 plus or minus. We've got underneath the radical, we have 5 squared, which is 25, minus 4 times 1 times 6. So 25 minus 24, which is 1. So we have the square root of 1 over 2. Perfect. This leaves me with x is equal to negative 5 plus or minus 1 all over 2. Let's separate these. So we have x is equal to negative 5 plus 1 over 2. Negative 5 plus 1 is negative 4. So negative 4 divided by 2 is negative 2. And let's find the second one. Negative 5 minus 1, well, that's going to give me negative 6. Negative 6 divided by 2 is negative 3. And there we have it. So actually, what I should have noticed from the beginning is that factors of 6 are also 3 and 2. So 3 times 2 gives you 6, and 3 plus 2 is 5. So I could have factored initially, but it didn't jump out at me, and that's okay. It's not a big deal. So I have my 2 x coordinates for the points of intersection. I just need to find my corresponding y's. So I'm actually going to plug these into the second equation. For me, it seems like that might be the easiest. So when x is equal to negative 2, we have y is equal to negative 2 squared minus 2 times negative 2 plus 2. So we're going to go ahead and punch this into our calculators. And negative 2 squared is 4. And then we have negative 2 times negative 2, so plus 4, and then plus 2. So we find that when x is negative 2, y is equal to 10. So there's my first point of intersection, negative 2, comma 10. We're then going to plug in when x is equal to negative 3. So we have y is equal to negative 3 squared minus 2 times negative 3 plus 2. Let's go ahead and do the math here. So we have negative 3 squared, which is 9. Negative 2 and negative 3 make a positive 6. And then, of course, plus 2. And that's going to give me 17. So when x is negative 3, y is 17. And we have just found the second point of intersection. Let's scoot this up, and there you have it. We're going to follow this same exact strategy for just a few extra problems. So we have parts C and D. Let's take a look at C. Y is equal to x squared minus 2x minus 1. And we're also told that y is equal to negative x squared minus 2x plus 5. The really great thing about this is that they're both equal to y. So I can literally take this expression and plug it in for y in my second equation. So let's check this out. So we have x squared minus 2x minus 1 is equal to negative x squared minus 2x plus 5. We're able to set them equal to each other because they're both equal to the same thing. They're both equal to y. All right, let's go through the motions of bringing all of my terms over so that I can set my equation equal to 0. So I'm carefully moving term by term. So that leaves me with a 0 on the right-hand side. And then I get 2x squared, negative 2x, positive 2x, they cancel. And I have minus 6. I'm going to factor out if I factor out my 2, I'll have 2 times x squared minus 3. So here's what I'm going to do in this case. I'm actually going to use the square root property. In order to do that, I've got to bring the 6 over. So check this out. You're probably thinking, wait, what the heck? You just moved all the terms to the left-hand side. I did, but I'm going to use the square root property like so. Let me show you. So I add the 6 over, and I'm focused on isolating my x squared term. So I'm going to divide by 2. I get that x squared is equal to 3. The opposite of something squared is to take the square root. So now I'm going to take the square root of both sides. Recall that the square root of x squared leaves you with just x, and that when we take the square root of both sides, remember, it's going to result in a positive and negative solution. So we have positive and negative square root of 3. All right. In this case, we are still going to plug into one of our original equations. It just might take a little bit more time. So we're going to plug in x is equal to positive square root of 3. And I'm going to punch this into my first equation. Why not? So we have y is equal to the square root of 3 squared minus 2 times the square root of 3 minus 1. Okay, well, the square root of 3 squared is just 3. Negative 2 times square root of 3 is a negative 2 square root of 3. And then we have minus 1. 3 take away 1 is 2. So I've just found my resulting solution. So when x is the square root of 3, its corresponding y value is 2 minus 2 square roots of 3. Remember that these are not like terms, so they can't actually be combined. If we were being asked to write a decimal approximation, well, that's completely different, but we're not. We need to provide actual solutions. So believe it or not, that's your first one. We're going to do this again, but we want to figure out what is y when x is negative square root of 3. So same exact idea. We have negative square roots of 3 squared minus 2 times negative square roots of 3 minus 1. So I'm just plugging in. The negative square root of 3 squared, negative times negative is a positive. Square root of 3 times square root of 3 is simply 3. Negative 2 times negative square roots of 3 is positive 2 square roots of 3. And then, of course, we have minus 1. 3 take away 1 is 2. So my second result, or my second point of intersection, is square root of 3, comma, 2 plus 2 square roots of 3. Those are my 2 points of intersection. So we're going to go ahead and write those in here. Square root of 3 and 2 minus 2 square roots of 3, and square root of 3 and 2 plus 2 square roots of 3. And we're done. How about we take a look at one more? So for part D, notice we have 2x plus y squared plus 6y plus 5 is equal to 0. And then we have x minus y minus 1 equals 0. I'm going to actually solve for x since I only have one x here. So might as well get x alone so I could just plug that in. So in order to do so, I'm going to add the y and add the 1. So that means my second equation is x is equal to y plus 1. I'm going to take this information and plug it into the x in my first equation. So I have 2 times y plus 1 plus y squared plus 6y plus 5 is equal to 0. Let's distribute. And then, of course, let's combine like terms. So my largest term is y squared. I'm going to write that first. 2y, 6y, that's 8y. 2 and 5 make 7. So we have y squared plus 8y plus 7 is equal to 0. Luckily for us, we can factor this, right? Factors of 7 that combine to give you 8, well, that's just going to be 7 and 1. Y squared, 1y, 7y, that's 8y plus 7, perfect. When we solve, we get that y is negative 7 and y is negative 1. Again, if I were you, plug these into the easier equation. So we're going to say when y is equal to negative 7, We have x is equal to -7 plus 1, which means x is equal to -6. Here, for your first point of intersection is -6, -7. We're going to do it again, except this time y is equal to -1. So x is equal to -1 plus 1, which means x is going to be equal to 0. So our second point of intersection is a y-intercept, 0, -1. So let's go ahead and write our solutions here, -6, -7, and 0, -1. On that note, now we have completed our Unit 5 notes for the 104 content, okay? Excellent work again. If you have any questions, don't hesitate to reach out. All right, everyone, enjoy.